There have been some debates on the internet about which direction a fan should be going, either away or into a VTX. So I decided to get the old thermal camera 2000X out of its case and test the theory. Should it be going away from the VTX or into the VTX? Let's see what I found. In this demonstration, I have chosen to use the Rocket Motor 8.4 volt 22,000 RPM brushless cooling fan. I believe that makes it digital, which means I cannot simply reverse the polarity to change the direction of the fan. I have to physically remove it and flip it over. So recently the phone rang and I had to go to work for 3 weeks, and this VTX has been sitting on a desk at room temperature since then. So I picked it up and I got the old thermal camera on it to show you that it's like, I don't know, around 76 degrees. And the first test we're going to do is put it up onto an 11.4 volt 4S battery and power it up. Our first test with the thermal camera is showing us with no fan on either side of the VTX, and after a minute it comes out around 95 degrees on both sides at 4S 11.4 volts. It's not that warm, it's nowhere near thermal shutdown. At 2 minutes we have 100 degrees on the MIPI side and 106 on the heatsink side. Still doing good. At 2 minutes we have 110 degrees on the MIPI side, and the heatsink side is 115 degrees. It's climbing. Okay, here's our 3-minute test. It's 122, 123 on the MIPI side, and the heatsink side is up around 125, 130, and at some points even 140. It's getting warmer. It's just sitting there. It's not in a drone with wind going over it. No fan yet, but we're going to get there. Stand by. Okay, this is our last test naked. It is at 130 degrees-ish, 120, somewhere up there, and getting warmer. And the heat sink side is all the way up there to 140, because that's where the heat comes from in these VTXs. You got to keep them cool or they'll go into thermal shutdown. So after running the thermal camera on the VTX while hooked up to 11.4 volts 4S battery, we went and soldered a 9-volt battery connector onto the power leads for the VTX, and now we're going to do the same test at 9 volts. You will notice that the temperatures are a lot cooler at 9 volts than they are at 14 or 12 volts, or I think you can run this all the way up to like 25.4 volts or 6S. I don't run anything that high, but you can if you want to. So I've chosen to use a voltage regulator to keep the VTX running at 9 volts in my projects. And here's the test with the thermal camera running at 9 volts. Okay, here we are. After 1 minute, I have sped it up to save some time in your life if you are actually watching this video. And after 1 minute, we're just up to 98 degrees on the MIPI side and about the same on the heatsink side, just a tad bit warmer. but it's going to go up from there, just not as hot as a 4S battery. So after 2 minutes, we see that the temperature on the MIPI side has actually come down a couple degrees, but the heatsink side of the VTX has gone up to about 104 or 105 because the heatsink is doing its job. And that's where we are going to see that the fan needs to be put on the heatsink side. But which direction? It's still a mystery. Stand by. All right, we're starting to see the lower temperature correlation at 9 volts here because the MIPI side is holding in the high 90s and the heatsink side is riding around between 100 to 105, and that's 35 degrees less than running it on 11.4 volts. So here we are at the 4-minute mark, and the MIPI side is holding in the high 90s, and the heatsink side, as you'll see here, is still around 100 to 105 degrees, therefore making 9 volts the happy spot for this VTX. And it's easy to achieve with a voltage regulator if you're not using a flight controller. This is the rocket motor brushless 8.4 volt 22,000 RPM motor. We're going to put 1 bolt through it just to hold it to the heatsink side of the VTX, and we're going to use the thermal camera to measure its performance, either ingesting air into the VTX or blowing away. One of the nice little details of this VTX are the threaded studs on the heatsink side to receive screws that are for the 20 or 25 millimeter fan, which is inadequate. And as you can see here, you can also use nuts or the threaded standoffs to act like a venturi for the air to get in or out from underneath the fan, because you need the air to go somewhere or come from somewhere once you mount the fan. Okay, we are using one singular 40 millimeter bolt to hold the fan onto the VTX. The fan is in the intake configuration where it's going to blow fresh air onto the heatsink side of the VTX, and we're going to test it. We're going to do this test at 11.4 volts because it's easier to see the temperature difference when we are switching the fan around. Our first test with the fan ingesting fresh air into the heatsink side, we're reading about 90 degrees, and it's going to go a little bit higher than that by the time our tests are done. Here's our test at 1 minute with the air coming into the VTX. The MIPI side is a little bit warmer than the fan side for obvious reasons, but the fan side is a lot cooler, but it's not the best solution. You'll see. So much cooler on that side. Keeping it cooler. A lot better than 140 degrees. Okay, here we are at the 2 minute mark with the fan blowing cold air onto the heatsink side of the VTX. The temperature has gone up by about 10 degrees on the heatsink side into the higher 80s. The fan is still working, but it's getting warmer. We're going to continue with this test. Stand by. Alright, here we are at the 3 minute mark with the fan coming into the heatsink side, blowing cold air into the heatsink side, and we're still in the high 80s and holding. The MIPI side temperatures are still holding, and reasonable temperatures are being had. So here we go. So it seems that the temperatures have reached an equilibrium, with the temperature on the MIPI side staying around 100 degrees, and the fan ingesting air into the heatsink is around 80 to 90 degrees, and that seems to be the happy temperature in this configuration. Let's continue the test. Alright, so now we're going to flip the fan over. The non-sticker side is the way the air is going to flow. I flipped it over, and we're going to be blowing away from the heatsink side. As we start the test with the fan blowing away from the heatsink side, we'll get a baseline temperature where the MIPI side is in the high 80s, and already with the fan only blowing for a few seconds, it's in the high 70s. I'm starting to feel something here. So on the MIPI side, the temperature is a few degrees cooler than it was with the fan ingesting air, and now cooler with the air blowing away from the heatsink. And the heatsink side is in the high 70s, low 80s. What's going on? I don't know. Here we are with minute number 2, with the fan evacuating air away from the VTX. And we see the MIPI side is in the high 80s. That's okay. The heatsink side is also in the high 80s, nowhere near 105 or 140 degrees when it was naked. All right, well, here's your final test at 4 minutes, proving that the air is better evacuated away from the heatsink than it is with the air being ingested towards the heatsink, keeping that side of the VTX in the low 80s. Way better. You may be inquiring why Mr. Markle would want to be worrying about which direction his fan is going. Well, this apparatus you have in front of you is the Moonlight VTX with the rocket motor fan mounted as we thought it should be, with the air going into the VTX. Well, this apparatus is going to be inside an RC helicopter, and very little ventilation inside there. So we wanted to make sure that while the helicopter was looking for GPS signals, that this thing wasn't cooking away before we engaged it to do the flight. So this test has proven that we need to have the fan blowing the air out, away from the heatsink of the VTX. This here project is about 98%, and you'll see that it has a dashboard just like inside an airplane. The processor is underneath that panel, and as it moves, that display changes. The antenna that you see, that little tan box on top of the dashboard, is a GPS antenna. It shows you speed, height, everything you need to fly a helicopter or an airplane. You can put this in an airplane. I'm going to be making a separate video discussing this FPV cockpit display situation. It's too much to go into at the end of this video, but it's very cool. It's got the Moonlight VTX system, and it's also got the dashboard display, and it's very cool. There are some programming options and display options and 0 instructions, so I had to reverse engineer the whole thing, figure out how it worked, figure out how to power it up without blowing it up, and I'll make a video about that soon. Thank you.